which is on key consuming segments, where we are going to discuss the current requirements of key industries, what are the water management practices, and what is the future demand. And for the same we have with us Mr. Arunava Das, who's the head water management Tata Steel, Mr. Sanjay Malani, who is general manager Jindal Steel and Power, and Mr. KV Suryam, who is vice president and COE Water Center of Excellence, Reliance Industries. A very warm welcome to all three of you, Mr. Das, Mr. Malani, and Mr. Suryam. I hope all three of you are able to hear me. Can I request all of you to please switch on? Can I request all of you to please switch on your camera so that we are able to see you?
Right.
Mr. Das, Mr.
Surya. Good morning, all.
So what I'm going to do is I'm going to quickly introduce all three of you, and then we are going to start with the panel discussion.
Sure.
Mr. Arunava Das, like I said, he is head water management at Tata Steel. He has over 3 decades of experience working in various production units of Tata Steel in different roles. His responsibilities included mechanical engineering and maintenance. Under his leadership, the company has undertaken various water-related projects to improve its water footprint, resulting in the reduction of freshwater consumption by nearly 62% despite a 40% increase in crude oil production. Today, the Tata Steel Jamshedpur plant is a benchmark in the steel industry for its efficient water consumption.
Correction, Nikita, it's good steel production, not oil.
Okay, sorry, sir. We also have with us Mr. Sanjay Malani, who is General Manager, Central Services, Jindal Steel and Power Limited. He has over 25 years of experience in steel plant utilities, both in India and abroad, and is currently responsible for EOT crane mechanical maintenance, water systems, local and track maintenance, workshop, HMV, and SMS slag handling equipment and mobile cranes. He's also leading a highly competent and motivated team of 310 members. We also have with us Mr. KV Suryam, who is Vice President, COE and Head Water and Utilities, the Center of Excellence, Reliance Industries. He has over 39 years of experience in water management, generation and treatment of water like desalination, both thermal and RO of large capacities, CW, BFW, complex effluents, PTA, refineries, steel plants, etc. He has also experienced cycling through tertiary RO industries like power, integrated steel plants, large refineries, and petrochemical complexes. Mr. Suryam holds a master's degree in chemistry and MBA and a postgraduate diploma in environment and ecology. He is a certified assessor for business excellence and certified lead auditor ISO 14001 and a certified TQM facilitator. A very warm welcome to all three of you, Mr. Das, Mr. Malani, and Mr. Suryam. I am going to ask a few questions from my side first, and then we are going to take up some questions from the audience. So my first question to all three of you is, sir, what are your current water requirements and how are you meeting them? Just to set a background for the entire panel discussion. And I would request Mr. Suryam to start first.
Hello.
Yes, sir. Yes, sir, we are able to hear you. Mr. Suryam, sir, are you able to hear me? Hello? Mr. Suryam, are you able to hear me?
Yeah, sorry, it got disconnected.
Yeah.
Now it's connected, I think. Yeah, I'm sorry.
Yes, sir. So, sir, my first question to all three the panelists, and I wanted you to start first, was what are your current water requirements and how are you meeting?
Is there a sequence or?
Yes, sir, I wanted you to start first, Mr. Suryam.
Okay, yeah. So good morning to all. Water management in any industry depends on various factors. One is availability, definitely, and at a cost, second, and third, statutory requirements or shortage, etc., or you have to generate your own water. So depending on various factors, industry has to operate within those constraints. As far as water availability is concerned, as of now, I think industries, or for the last 5 years or so, industries have started feeling the pinch. Once water is not available, then you are forced to go for maximum recycling. And as a practice, almost all the industries now in India, I think, have accepted this fact and going for maximum recycling of the wastewater, limited to maybe 75 to 80% recovery of the wastewater through various means, either secondary treatment or followed by tertiary treatment, including ultrafiltration and RO. But that being a small factor as far as total availability, total requirement of water is concerned. So all the industries are dependent on external sources of water, unless it is your own desalination plant, as we have done at Jamnagar. Otherwise, mostly it is surface water or the treated municipal sewage, if it is made available in the right quality and right quantity, and with an assurance that no disturbance will be there throughout the year. So within those constraints, options are many for industry. Technology-wise, I feel it's not at all a big issue. It's all depends on the availability, statutory requirements, the rules of the rules applicable in those particular areas, and of course, cost is definitely a factor. So under those constraints, all the industries are operating, and we have successfully sailed through any such eventualities which we saw in the last couple of years. And we go for maximum recycling. Invariably, entire water, be it cooling water, tower blowdown, DM plant effluents, boiler blowdowns, and treated effluents in large quantities from various process plants. And of course, the STP water within the plant premises or within township are recycled through ultrafiltration and RO. Recovery rates are also very high at about 75%. Of course, that depends again on your TDS, total dissolved solids level, and this CODs to what extent you will be treating those secondary treated effluents. So under those, I won't say constraints, but yeah, under those challenges, definitely we don't see any issue as long as the fresh water is available. And where it is not available, as I told, our 100% requirements we meet with through desalination. We have almost 450 MLD desalination plant at Jamnagar, a blend of thermal as well as seawater reverse osmosis. Yeah.
Sir, in terms of volume, what is the quantity of water consumed by Reliance? Sir, I think I missed that figure.
So it all depends on site to site. We have manufacturing sites at various locations, but the largest consumer being at Jamnagar, requirement is at Jamnagar, is close to 85 to 90 MGD, or roughly 450 MLD of desalinated water.
All right.
What is happening in this connection?
Sir, I'll come back to you with
Are you able to hear?
Yes, sir. I was able to hear your answer. Sir, I'm going to come back to you with more specific questions later. Now I'm going to move to Mr. Das. Mr. Das, if you could also talk about the kind of water requirements that you have at Tata Steel, and how are you meeting those requirements?
Tata Steel is fortunate, and our forefathers have selected this place because of the abundance of water available. And the rainfall at this part of India is quite significant. And there is a dam upstream, so we never felt the pinch of water shortage. But the steel industry consumes huge amount of water after thermal power plants and pulp and paper industries.
Sorry.
So it requires huge amount of quantity of water as well as required good quality of water. So since we are sharing the common water bodies with the local communities, and the population over here in India is growing significantly. So to avoid any conflict in coming days, we have started reducing our water consumption. But in particularly Jamshedpur plant, since it is both a 100-year-old company, so the process-wise improvement is not always, feasible. So whenever we have gone for any modification or any upgradation of plant, we bought in the cutting edge technologies which is having lower water footprint. But for the plants which is 25, 30 years of age, it is not always possible to go for the process-wise improvement. There we have taken the policy of reuse of bad quality of water for the low-end applications and recycling of maximum. So initially we started with recycling the in-house effluents. Then later on, since we are having our own township, and that is one of the best township in India where the entire sewage generated is collected in two particular STPs. So we started recycling in those STPs, and right now I can say proudly that the 100% township is sewage free. I mean to say that no discharge from the township is happening in the river. The entire sewage water we are converting it to the clarified water quality, and we are using it in our industrial purposes. And that's how I said that we reduce our freshwater consumption more than 62%, despite 40% increase in steel productions. And the majority is recycling. We are having one common effluent treatment plant within the plant to recycle the effluent generated inside the industries, which is having 5 MGD capacity, and we are going for 9 MGD. And we are also going to adopt the zero discharge. There is a small concern, I would say, that technologically all the technologies are available to recycle any quality of water. But the two things are really concerned. One is cost, and the second thing, if any UFRO processes, there will be certain amount of rejects generated, which is highly concentrated. Okay. So dealing with that reject should be taken care of. It is not that you are taking out the good quality of water out of effluent and concentrated liquor you are discharging out. So that should be avoided. Okay, so proper use of rejects also needs to be taken care of. The other thing, I was going through the some part of the last discussions. So I would like to the power industries, there will be a law coming up. In fact, that law is available right now. So, any new thermal power plant should be given the sewage water for their processes. They will have to treat the sewage water, and they will not be given any kind of fresh water. And this is the writing in the wall we can see for any industries upcoming, which is beside any township or anywhere. You have to either treat the sewage if it is available, or you have to collect it. You have to make your own system to collect the sewage and treat it, because it is cost-wise also it is very cheap. So I can give you a cost example. Raw water from the river which we withdraw is around 11 rupees 30 paisa per meter cube, and it is 7.5% increase year on year. But the water we treat, the sewage we treat, including the capex cost, depreciation cost, and treatment cost, it is coming somewhere around 5 rupees 40 paisa. So the cost of that water, entire capex would be come out within 2 years or 3 years down the time. So the industry should think in this line. And I know that the the Hindustan Zincs, they have taken entire sewage from the Udaipur cities, and they are taking it all the way 130 kilometers away to their plant for their industrial application. So this is the future, because we have to avoid the conflict with the local communities, and the first right for the water, fresh water, is lies with the communities. We have to keep it in mind that we need to focus more on recycling and reuse. And as I've seen one question that what is the consumption of steel industry? I can say steel industry's water consumption is hovering around 4.5 to 3 meter cube per TCS. But the guidelines given by the government, Jal Shakti Minister, is to reach below 2.5 meter cube per TCS. But Tata Steel Jamshedpur plant is right now operating at 2.25, but there are other two plants which is around 3.5. So we need to work on over there also. So that's all for right now from my side. So I'm Right?
Thank you, sir. I'm going to come back to you with specific questions as well. I'll move to Mr. Malani now. Sir, if you could also share what are the current water requirements at Jindal Steel and how are you meeting them?
Very warm good morning to all. I am representing JSPL, Jindal Steel and Limited. As you are aware, is an industrial powerhouse with a dominant presence in steel, power, mining, and infrastructure structures. With a team of experienced professionals, we have our manufacturing facility at Raigad, Angul, Oman, and other various locations in India and overseas. I am representing JSPL Raigad, which is a 3.6 million ton per annum steel plant with a state-of-art technology comprising of 2 blast furnaces, coke oven, sinter, DRI, and EAF. We have this 100 MT3 EAFs, LRF, VD, casters, and versatile mills comprising of RUBM, plate mill, MLSM. We are the only producer of rails apart from SAIL, the light steel plant. Now, coming to our water requirements, we have around a consumption of 20.8 MCM per annum of water consumption in this location. As rightly said by Suryam sir and Mr. Das, the availability is a major concern of water. Then requirements, cost of water plays a vital role in steel. So we are consuming around 20.8 cm water per annum, and presently we are able to supply water as per demand. So there is no demand supply gap as such. And our sources of water are 2 rivers. Basically, one is Mahanadi River, where we have a contract of around 12 MCM of water per annum. That is 1 MCM a month. And another is a Kelo River, with which we have around 8.8 MCM of water. And the last 30 years, we are drawing water from sources, and we are able to fulfill the requirements. As rightly said by our colleagues, we are also have the same water using, we are reusing, recycling. We have a STP plant, PTP plant, and this STP we are using in our horticulture, and we have a very good township where we have this potable water and other are supplied by this water treatment plants. Then we are also focusing on this ZLD, that means zero liquid discharge from the plant. Coming up to the next, what are our current water management practices? As I have informed, we have 5 water reservoirs in our plant with a capacity of around 1.4 MCM. And in future, we are planning to improve our storage capacities. Few difficulties I will come up with, we are usually with the water needs. Since we are drawing from the downstream of rivers, it becomes difficult during the summer to maintain the water levels and withdraw water from river, so which is a major concern. Then since the plants have come in bits and pieces of what we call reservoirs at various locations supplying different units, so that becomes a concern. And we have these lines now from last 30 years, so we are replacing in phases since it has become old, and this corrosion are major concern for us. So we have leakages and other problems also. So we are replacing the lines. So sometimes we have this villagers problems, pipeline maintenance works. These are our the major concerns. And we are planning for capacity enhancements of the plant. So also planning to go for new contracts. We are coming up with new facilities exploration. That's all for now.
Thank you, Mr. Malani. I'll come back to you with the more specific questions later. I'll move to the second round of questions, and I'll start with Mr. Suryam again. Sir, you had mentioned that I know that Jamnagar refinery has the largest desalination plant. So what exactly is the cost of production for the desalination water that you are producing? And sir, are you also relying on fresh water, or is the water requirement being entirely met through the desalination plant that you have at Jamnagar refinery?
Yeah, it's 100% desalination plant.
So
There is no water at. Yeah, it's 100% through desalination only. There is no fresh water available. Only Narmada water is made available to Jamnagar and up to Dwarka for drinking water purposes only in small quantities. I think SR has got some consumption of Narmada, but normally it's very, very small. I mean, negligible. So our entire desal capacity, which is around 17 to 18,000 cubic meters per hour, or 90 mgd roughly, if I can call it. So is met through desalination. It's a blend of thermal as well as RO. Coming to your first question, the cost of desalination. In India, roughly on an average, I mean, as a ballpark number, the costs are varying depending on the intake sources, etc. Capex wise, it will be, as a ballpark number, 25 crores per 100 cubic meters. The cost capex wise absolutely very high, and opex wise is roughly 25 to 30 rupees per cubic meter per kiloliter. It again depends on what is your power tariff, but about 5 rupees if you take the power tariff, 5 rupees per kilowatt hour, it will be about 25 to 30 rupees. It will be varying in that range. And life cycle cost wise, again it depends on financial models. Like Chennai financial model, it is about 45 to 48 rupees, I think, per kiloliter, but on a 20 years BOO basis.
and sir, what is the production cost in case we compare it with the tariffs that are being used for fresh water? The production cost must be really high for you.
Is it audible?
Yes, sir.
Yeah. Okay. Yeah.
Yes. Sir, I was asking you, what about the production cost of the water as compared to the fresh water that the industries are using? It must be really high.
Yeah, that's what I told. The production cost of water will be about 25 to 30 rupees per kiloliter, but it is only OPEX. But if you take the life cycle costs, it will be definitely quite high. And for 20 years payback period of financial modeling, it will be anywhere around 50 rupees per cubic meter, as compared to fresh water, which is throughout India is made available at around 25 to 30 rupees. Of course, it's varying from state to state.
Yes, sir. And what about the energy consumption at your desalination plant? Sir, what are these a few initiatives that you have taken over the years to reduce the energy cost component in the total cost?
So energy cost components are always driven by 95% is driven by or dependent on the quality of seawater which you are tapping. So your tapping point also or intake point also is very, very crucial, whether it's a neat and clean, crystal clear seawater, like we see in Israel, wherever we visited before installing our plants, or even Western Ghats. But in this side of the area, and even in many coastal areas in India, because of the pollution loads, etc., the water is definitely dirty, I would say, in terms of turbidity mainly. And the dissolved solids assuming that the dissolved solids are at around 40,000 in Indian sea coast and a turbidity level of anywhere between 100 to 500 ppm. The energy costs will be varying or hovering at around 4 kilowatt hour per cubic meter. Again, it depends on your plant layout and design, of course.
All right. Sir, I'm going to come back to you with specific questions later. I'll move to Mr. Das now. Mr. Das, you had mentioned about the kind of initiatives that you have taken and what are the facilities that you have set up. So what is currently the tariff that is being paid by you for the water?
See, I said also that the present tariff is around 11 rupees 30 paisa per meter cube. And after treatment and all, we receive at our factory end is around 15 rupees something, around 16 rupees at the ballpark number. But we are also treating, as I said, the sewage water which is making this water a bit cheaper, because we are having 30 MLD sewage water. And looking at this cost and the quality of water, we are thinking to upgrade this plant, and we will future collect more sewage from outside the township being maintained by Tata Steel. So because it is having cost efficiency also. Apart from that, we are having one common effluent treatment plant, which is treating the effluents generated within. That cost per meter cube is coming around 16-17 rupees. Okay, and because as I said, energy is one of them. Energy cost is a bit high, but fortunately, the energy cost in Jamshedpur particularly, because entire power is being generated by Tata Steel only, so it is coming around 3 rupees 80 paisa. So taking if we can take the normal cost of power, so it would be a bit high than that. The second good thing is that we don't have to treat the RO reject, because there are lot of low and consuming, high temperature consuming points like slag quenching, melting chops, then blast furnace slag quenching, then coke oven quenching. So where these rejects are being used, so that no tertiary treatment or evaporator crystallizers are required. Yes, for the upcoming one plant which will treat the coke oven byproduct water, which is the highly contaminated water, for that we are getting one evaporator crystallizer to be zero discharge, and by 2023 FY 2023 we will be zero discharge company.
So you had mentioned that you are also planning to expand the capacity and collect sewage outside the township. So, sir, are you going to be in contact with some ULB or have an arrangement with some ULB for this, or do you plan to lay the collection system or infrastructure also?
The advantage over here that this township is entirely maintained and operated by Tata Steel. So whatever within the leasehold area, that 100% sewage is being collected, and there are two huge sewage treatment plants where it is being treated. What we did that we put up tertiary treatment plant in those two sewage treatment plant, and we have taken that tertiary treated water for an industrial application. And since the Tata Steel is, having the dominance, and the other Tata Group companies are also available in the Jamshedpur city, we are thinking of to get more, sewage from the other areas where it is simply, discharged to river. So it will having an advantage that the no sewage water, being discharged to the river, it will reduce the pollution, as well as this will help us to reduce the dependency on fresh water. Okay, so we are having a target to being water positive. Tata Steel Jamshedpur was water positive by 2025.
Mm-hmm. All right. I'll come back to you, sir, with more specific questions and move to Mr. Mani now. Sir, if you could also share with us the tariffs that you are currently paying for the water you consume.
We have water charges of ₹5.50 per cubic meter, and since we have from the downstream we are taking the water, others are around ₹10 per cubic meter. Plus that energy cost, they are costing since we have our own captive power plant. Per kilowatt cost is around per unit cost is around ₹4. So including that ₹3.51 of energy, it comes to around ₹9 we are having that water.
Thank you, sir. I'll move to Mr. Suryam now. Mr. Suryam, if you could share with us what is the kind of effluent that is being generated at Reliance, and what is the treatment capacity that has been set up for effluent?
Well, be it refinery petrochemicals or integrated steel plants. I was head of water management at Vizag Steel before I joined Reliance about 15 years back. So this effluent generation is huge in these two plants. And a variety of effluents, constituents which are there in the effluents are the biggest challenge to treat, be it hydrocarbons, complex hydrocarbons or heavy metals or cyanides or etc. But yes, technology-wise, the water treatment is quite matured, so that's not at all an issue. And we spent heavily on effluent treatment plants. And invariably, all our effluent treatment plants have downstream ultrafiltration and RO for recovery of maximum possible water. So our recycling capacities are also very high. The effluent generations are in the range of 1,000 to 1,500 cubic meters per hour, I am talking. And all the plants have got invariably the ultrafiltration and RO for recovery, and the recovered water is made up to the cooling towers or blended in as a feed to DM plant for better efficiencies.
Thank you, sir. I'll move to Mr. Das now. Sir, if you could also share with us the effluent generation figures and what is the kind of treatment capacity you have.
Earlier in 2015-16, approximately 15 MGD, million gallons a day, of effluents generated out of this our plant. And out of that 15 MGD, we started recovering that water. We have created catch pits in all the drains, started recovering that water, and wherever possible, we have given this effluent water directly for low-end applications, I said. Because steel industry is having some advantage that there are few processes where you don't require good quality of water, only the quantity of water, any quantity of water will do. So there we have provided these lines, and rest, as I said, 5 MGD we have taken back to CETP, common effluent treatment plant, where we are recycling it and convert 85% recovery from there, and we have injected in the freshwater network. Still, there are 4.5 MGD of water leaving out the premises, for which the work is going on. As I said, 1 TTP for biological co-commence discharge, which is the most pollutant water, as it contains phenol, cyanide, ammonia, high COD, high BOD, everything. So for that, a TTP is coming up. It will be 1 MGD, and rest 3.54 MGD will take back to the CETP. And finally, the CETP capacity will be 9 MGD and 1 MGD of this TTP. That will make the entire Tata Steel Jamshedpur plant zero discharge.
Mr. Das, if you could also share with us, like you have a plan to set up 1 MGD tertiary treatment plant and increase the capacity of the CETP also. Sir, when are these, what are your plans? What are the timelines and the targets for these? When do you plan to come out with the tenders for these, or are these already ongoing initiatives?
The tender for CETP phase 2 is going on. Some part already given. So it will be over by 2021 December. And for TTP, all the ordering and tendering has already been given, and it will come up somewhere in between June to August 2020.
All right. Okay. I'll move to Mr. Malani now. Sir, if you could also share with us the kind of effluent generation, the figures for effluent generation, and what are the treatment capacities that you have set up?
Presently, we have 6 STPs of various capacities put up at various locations, totaling to around 5,100 KLDs. And these we are using in horticultures and other areas. We have ERS. We don't have presently ETP. We are planning to put up ETP in future, but we have effluent recycling systems. And whatever these effluents coming up, we are using in low-end applications where we have the advantage in steels. So we are using for ash handling systems where we are taking up to the ash dikes. Then we are using for slag pinching and other applications. So we are utilizing in such areas, these low-end applications like ash handling and slag pinching.
Sir, you had mentioned that you do have plans to set up ETP. So, sir, do you have any timelines or is there any capacity in mind that you plan to set up for ETP?
Not presently, we are exploring.
All right, okay. I'll move to Mr. Suryam now. Mr. Suryam, I just wanted to understand what is the kind of regulatory landscape that you have in Gujarat. If we just talk about the Jamnagar refinery, what are the kind of regulations are there in place overall for the industries to restrict use of fresh water as well as groundwater, as in surface and groundwater both?
I think Gujarat has banned use of groundwater. So nowhere, no industry is allowed to use groundwater. But otherwise, wherever fresh water is made available, they are being used, and all the discharges are as per regulations only. I mean, no industry can operate out of regulatory requirements.
I have the same question for you, Mr. Das. If you could also talk about the kind of regulations that are in place in your township or outside that, how are you restricting the use of fresh water, be it surface or groundwater, by industries?
So no groundwater being used in any of the Tata Steel plant. Only the fresh water is from river. And as said by Mr. Suryam, that nowadays all the norms are being getting stringent and it is being followed very strictly. So unlike earlier days, no industry can do any hanky panky to get rid of all these norms. They have to abide by the norms given by the for where different kind of industry, different norms are being set. So for steel industries, it is TSS, COD, BOD, pH, then cyanide, phenol. All this needs to be monitored at the discharge level, and we are well within it. And we are having the model analyzers room, which measures this water online, and directly these data are being fed to Central Pollution Control Board as well as the State Pollution Control Board. So there is no chance of being get rid of if in case of any failure or anything. You will be captured of it. So you have to be on your toes, and you have to maintain all the norms.
Thank you, sir.
These norms are getting stringent day by day.
Yes. I'll move to Mr. Malani now, sir. If you could also share the kind of regulatory environment or the landscape that is there, and what kind of restrictions that are there, and how the state government is ensuring compliance or enforcement of these norms.
In Chhattisgarh also, we have strict norms. No groundwater is allowed to be used. So same this river waters, what are available, we have been utilizing in all the plants. Although for remote areas, when drinking water applications, this borewell pumps are utilized. Otherwise, no such very strict norms are there. Nowhere we are using this groundwater or anywhere else.
Thank you. I'll move to Mr. Suryam now. Sir, in your vast experience with Reliance also, sir, how has the water use efficiency and water footprint improved over the years? And what are some of the innovative tools and technologies and solutions that Reliance has adopted to improve the water footprint and water use efficiency?
So we have adopted each and every bit of technology whichever is available across the globe. So we have the most modern, as I said, ultrafiltration and downstream RO. We are using MBR, membrane bioreactors, for high COD effluents. We digest CODs, high CODs in anaerobic digesters and produce methane gas. The gas from the digested COD is utilized in our Dowtherm heaters, etc. So energy-wise, water footprint-wise, maximum recycling, the best practices. We have standards and best practices in water. We have developed many standards, almost 15 standards. Cooling towers, we operate at very high COC cycles of concentration, minimizing the blowdowns. We operate at as high as almost 10 to 12 COC. and the blowdowns are also taken to ETP for final recovery again. We blend the water in such a way that the calcium magnesium do not create problem in RO scaling, etc. We use the DM plant high concentrated TDS water also in for recoveries. So blendings are also done in a proper manner depending on the quality and the TDS and the recovery rates and the limits in anti-scalants, etc. We also use cascade use of cascade way the water is used, the little lower quality to a process where the process requirements are not that stringent. So I would say we operate beyond those typical 3R, no? Recovery, recycle, reuse, etc. It's ours is a highly integrated total water management system, which is site specific or project specific. Right from project stage itself, the total water management concepts are adopted. I developed many such practices, concept papers, which was later given to DEC's design and detail engineering contractors for incorporating them. So every stage, right from project stage onwards, the water recycling and total water management concepts are adopted. So it's a extensive use of water and minimizing the footprints to its lowest levels.
Thank you, sir. I'll move to Das now. Sir, if you could also throw some light on the kind of water use, how the water use efficiency and water footprint has improved over the years, maybe in the last 10 years, how, or 5 years, maybe how it has improved. And what are some of the initiatives that you have taken to improve it?
It is same as said by Mr. Suryam, that it is basically 3R principles. And as I said in the beginning, this plant is mostly 75% of the plant is mostly more than 25 years old. So reducing process-wise is not possible. Despite that, we brought in technology like coke dry quenching to eliminate the wet quenching of coke. We put up, and it is very costly affair. Each plant is costing around 700 crore rupees. So we bought in two of it for 5 number of batteries. But since space is a big constraint for Jamshedpur plant particularly, so we couldn't go for the other 2 batteries. And as being said by Mr. Suryam, that we are following all the three R's: the reduce, reuse, recycle, whatever possible. And it is mostly area specific. The kind of water you receive, the kind of technologies you are having, and all these things. And we are fortunate that steel industry is having bit fortunate to have. There are many applications, as I said, that where the quality of water is required, not the quantity. So these RO rejects, all the low kind of water, whatever blowdown waters, it is being used, given to those areas for these purposes. So it is basically stringent use of 3R principles. That's it.
I'll move to Mr. Malani now. Sir, if you could also share, throw some light on how the water use efficiency and water footprint has improved over the years for Jindal Steel.
Very well said by Suryam sir, and he has defined this high technology, how they are there. As said by Das sir, in steel plants, we are lucky that we have low-end applications of water, just like areas where we require low quality of waters, like this ash handling areas. Then we have this what you call slack quenching, where we are using this cooling tower blowdowns. Then we have this high TDS water of softeners, DM plants, and these 3 R's are being very well utilized. Recover, recycle, reuse. That is the sole policy for us also, and we are also following this.
Thank you. I'll move to some audience questions now from the delegates. And this what I wanted all three of you to also answer. I'll start with again Mr. Suryam. Sir, there's this question from a delegate, Mr. Ghulam Mustafa. He's saying, what is the driving force for going for the zero liquid discharge? And sir, are the facilities already zero liquid discharge? And what is your thoughts on zero liquid discharge for the industry overall?
So zero liquid discharge was a buzzword which was being used for many years by the industries. But strictly speaking, zero liquid discharge is statutory driven. It's very difficult for any industries to go for zero liquid discharge on their own, unless it is a pharmaceutical industry or a heavy metal industry or chrome plate industry, etc., where you are not allowed to discharge anything, or it's a union territory where the laws are very clear that it has to be ZLD plant. Zero liquid discharges are abnormally costly, abnormally capex oriented and opex oriented, where industries like us, we have gone for 75% to 80% recoveries of any effluent. But the tail end recoveries are abnormally costly for any industry where dissolved solids are very, very high, more than 15,000 ppm. Invariably, you have to go for multi-effect operators and crystallizers. The costs being abnormally high, it will not be less than 1.5 to 2 crores per cubic meter. 1 cubic meter alone will cost you about 2 crores. So think of a plant where the discharges are in the range of like steel plants or any heavy industries, where the discharges are almost 200 to 300 cubic meters per hour. The capex wise, it's abnormally costly. OPEX also is highly abnormal. It's somewhere around 200 rupees, 150 to 200 rupees per kiloliter per cubic meter. Because cost of steam will be very high for operators. And the cost of power for crystallizers is anywhere 15 to 20 kilowatt is required per cubic meter to get the final crystals. And the biggest challenge is, bigger challenge is, what do you do with the salts or dry solids recovered? For such large cubic meters or water flows, the dry solids will be anywhere between 5 to 10 truckloads of solids per day. So where do you dispose it of? Then again, it calls for a hazardous waste disposal mechanism. Then it is called for secure landfill, or you need to find the agencies, Central Pollution Control Board approved agencies who will take these discharges for secure landfills. The costs are abnormally high. I mean, what I would say is not at all practical. And that's why the statutory bodies are also clear that it's impossible unless it is pharmaceutical industry or chrome plating, where the total effluent, final effluent, tail end effluent will be about 1 or 2 cubic meters only per day, which a small solar pond or a small operator crystallizer would be sufficient in a 10 by 10 meters area. But not for the large industries, absolutely not. I don't think anywhere world over this ZLDs are imposed on industries also.
Right. I'll move to Mr. Das because I remember one of the initiatives that you had mentioned was zero liquid discharge. Mr. Das, what are your thoughts on the same?
Yeah, it is absolutely well said by Mr. Suryam that this is actually practically not possible. Not possible in the sense we should change the terminology from zero liquid discharge to zero effluent discharge. Basically, it should be zero effluent discharge, and most of the industries, there is no separate drains for effluent as well as storm water. So getting zero discharge, particularly during the month of monsoon, is absolutely not possible. The second thing, the cost. Even if some of the process you put in evaporator crystallizers, so finally, what you will do with the salts generated out of it, because it is highly toxic and highly hazardous. So similarly, you have to find out a way to get rid of these salts generated out of it. And I have seen 1 or 2 plants where pile of these salts being kept and there is no space further to keep this salt, because there is no space to discharge it in secure landfill and all that. There are one or two vendors approved by the government like Ramke and all, but the charge they charge huge. They for 500 to 600 rupees per meter cube on this discharge of the salts. So the government as well as the industry should take it as a whole. It should be a win-win situation, and it should not be that because the cost of treatment, as said by Mr. Suryam, that it will be somewhere around 2 crore rupees per meter cube for the evaporator crystallization, and the OPEX is not 150, it is more than 200 for these cases. Okay, per meter cube. So it has to be taken care and discussed with the government agencies, and it should be a win-win situation, because it is not always possible for the small industries, and particularly in steel industries, huge amount of influence are being generated. So wherever possible, you should use it in the low-end applications, but particular few processes there are after the RO rejects cannot be used directly, because it will corrode your structure and it will having some other issues also. So it is a terminology now imposed by the government, and industries are still in dilemma whether to go for GPO discharge or not. So it still needs to be matured, and it still needs to be looking at a totality.
Thank you, sir. I'll move to Mr. Malani. Sir, do you have any thoughts on the same?
Precisely speaking, I also believe that this is not at all practically possible. Secondly, it's a very costly affair.
Yes.
Care that it is a effluent discharge. The water is not hampering the crops and others of the nearby farmers, or affecting the aquatic growth in the nearby ponds wherever it goes out. So this is what we are ensuring.
I'll take some more questions from the audience, and this one I'm going to request Mr. Suryam to answer. Sir, this is also from Mr. Ghulam Mustafa. He's saying, what is the current regulatory norm for discharge of RO reject to the sea or any surface water in terms of TSS, TDS, and metal ions?
Again, it depends on state to state. It is pollution board to state pollution board to state pollution board. Normally, when statutory authorities say that you recover the water to its maximum requirement, they are liberal in RO discharges. Either, both cannot be applied together. That you install a recovery plant and then don't allow you to discharge the effluents. In a typical industrial environment, the TDS levels varies from 1000 to 2000 ppm or maximum 3000 ppm in the effluent feed. So your reject RO will be somewhere around 10 to 15,000 ppm or so. So these are allowed, but if it is a surface creek discharge, their norms are little liberal. But if it is a river discharge, then dispersion modeling studies, etc., have to be done. But as I said, it again depends from place to place, varies from place to place.
So there is another question for you. Do you see any change required in technology for better process in wastewater treatment and or RO desalination? If yes, then why?
I would say technology-wise, water treatment has matured enough, but understanding-wise, the software part of water, if you can call it, the quality, ionic balances, scaling potentials, polling potentials, pre-treatment requirements. Many people think that RO is a high-end technology. In my opinion, RO is just a filtration plant. High-end technology from understanding point of view is pre-treatment. Although it's age-old technology, but maximum negligence is done in pre-treatment, and that's why RO plants gets buggered up. So if your pre-treatment is, you spend is a 99/1 rule, not even 90/10 rule of Stephen Covey. It's a 99/1 rule. If you spend one unit of energy, time or efforts or money in pre-treatment, your 99% improvements are seen in RO. Second most important plant is technology wise, it's okay, but understanding the technology and applying the technology, those skills are missing now in water treatment. Majority of the people for the last 20 years also have diverted to software. Remaining people are now preferring the sales, marketing, financial sectors. Out of that, remaining people prefer production units. So water treatment people pay a little less interest. But again, the most challenging area is water treatment. The area is very vast, very deep. After this 35 or 40 years of experience, still I feel that I am floating on the surface of the water without knowing what is the depth. And you find that water experts are available everywhere, right from arts graduate to commerce graduate. Everybody feels that he is an expert in water. It's so simple. So these are the challenges in which the water treatment industry or water management is operating. But yes, the industries who realize that it's a very, very critical area and this 90-10 rule is applied. Here, you don't pay 10% focus, 99%, 90% problems will be cropping up in your production units. One small heat exchanger leak on account of poor water treatment will cost you hundreds of crores in a major industry.
Thank you, sir, for your answer. The next question I'm going to request Mr. Malani to answer. Sir, what kind of pipelines are used for transportation of water and discharge? Is there any water loss in water pipelines?
We are using MS pipes, both internal and externally coated from rivers to the reservoirs. And yes, obviously there is loss of water as they are getting older due to corrosion and other. We are facing this problems of water loss from the pipelines and are arresting the leakage from time to time wherever they are.
So what are the specific initiatives that you are taking to address this water loss because of the pipelines?
In a planned way, we are replacing the pipes. See what happens, these were laid some 25 to 30 years back. So now due to expansion also, the roads have widened where these pipelines have come up under the concrete roads now. So we are compelled also, and considering the losses, we are rerouting these lines and as per the availability and routes available with the WRD, we are phases these pipes.
Thank you, sir. Next two questions are related to Tata Steel, so I'll request Mr. Das to answer them. Mr. Das, the first question is, in Tata Steel Limited, do you use the Jamshedpur sewage also?
Yes, as I said, 100% of Jamshedpur sewage is being treated and used in industrial applications.
Thank you, sir. The next question is whether in Tata Steel coke oven byproduct effluent are recycled back after treatment.
Now, as I said, the coke ovens byproduct, the liquor, whatever comes out, there is a BOT plant. It's a huge plant where all the effluent parameters are bring into the below discharge norms, and then after dilution we are leaving it, discharging it. But as I said, that the tertiary treatment plant is going, it's on the project stage, and by 2022 July or August, it will be over, and this effluent will be 100% made zero discharge.
Thank you. Before I close this session, I would request all three of you to please give your closing remarks. What do you think is, the outlook for the industrial waste management segment? Where do you see in terms of waste management or water management in the next 2 to 3 years? I'll start with Mr. Suryam first.
So the pressure on industries is building up both from statutory requirement point of view, then mostly availability of water point of view. Definitely agriculture and municipal requirements are prime. So industries, those who were operating for the last 20-30 years or so on a particular water source, or it is becoming difficult for them to source the water. So governments are also contemplating to use alternate sources of water, which is undoubtedly either seawater through desalination or as once through, but that is limited to only coastal zones. So the more focus in coming years will be in municipal sewage, which Ministry of Jal Shakti is also contemplating in a major way. So municipal sewage, already there is a requirement that within 50 kilometers for power plants you have to use municipal sewage, but for more or less all industries, including in Gujarat and of course entire India, I think it will be applicable. But yes, municipal sewage is a very simple, easily available source of water wherever A, B and C class cities networks are well laid. The treated sewage is being discharged. So that water, if you can tap, either you invest the capex or the municipal bodies invest the capex for tertiary treatment plants and supply you water. But it's better if you invest and get the water. But it has to be made freely available so that there is some incentive for the industry. And the treatment costs will vary somewhere around 15 rupees or so OPEX wise. CAPEX wise, again, it depends on the quality of sewage. And it's a permanent source of assured source of water for the industries. But yes, industries should change their mindsets and get prepared for this change. That's important.
Mr. Das, so your closing remarks? I think he's facing some internet issue. I'll ask Mr. Malani first to give his closing remarks, and then we are going to go to Mr. Das.
Nice listening to Suryan, sir. I will say the quality of water plays a vital role in quality and quantity of steel. Major concern is this disposal and consumption of, I should say, rejects of RO. The availability of water. So we have to plan for the future projects also, and accordingly take actions to improve our and make the systems more efficient.
Sir, Mr. Das, would you give your closing remarks? I can't see Mr. Das here right now. I think he's facing some internet issue. Sir, there is one last question for you, Mr. Suryam. I would request you to answer it. So this is from one of the panelists, one of the participants. What is industry expecting per KL cost from sewage treatment plant? Will you recommend own operation or outsourcing?
Yeah, this is a very tricky question. I mean, rather a challenging requirement. Wherever municipal bodies are giving you sewage free of cost, secondary treated sewage, first the quality has to be assured that within those BOD, COD and TDS limits you get the sewage. Then who will install the plant? Again, it's a mutual understanding between municipal sewage. The moment you approach, then the costs of sewage again are being hiked up, and it becomes economically unviable for you to install your own plant than play to the tunes of the municipal bodies. So it has to be made available free of cost to an assured quality and quantity. Then industry can install their own treatment plants. The capex wise, it will be around somewhere around 15 crores per 100 cubic meter. Of course, depends on the land and power availabilities, etc. I am assuming that land is made available free of cost. Then OPEX wise, it is around 15 to 20 rupees, depends again on the transportation costs, etc. But typically around 15 to 20 rupees. So if sewage is made free, available free, then OPEX of 15-20 rupees and CAPEX loading has to be done accordingly depending on the paybacks. So it's not technology wise, it's the financial modeling and the statutory requirements are the ease of doing business with the government or municipal bodies. These are very, very crucial in this area.
Thank you, sir, for answering it. Mr. Das, are you able to hear me? Are you back? I think he's facing some. Yeah, you're back, sir. Yeah. Yes, sir. Yeah, sir, if you could give your closing remarks, sir.
This water technology the future of any industries, because water availability is going to be reduced day by day, and you have water management systems available in your plant. Otherwise, it will be very difficult for the long-term sustainable for any industries. And for that, you have to use all the technology, not only 3R, it is basically 4Rs, where you have to ensure the recharge of the groundwater as well, so that, and rainwater harvesting is the future for most of the industries where the water consumption is a bit less. So we have to look into water holistically, and this technology, this field is going to be increased day by day, and in the coming days, more of engineers and more of technical people will definitely get into it. Only as if any graduates are now dig into this water business. Yes, because it was earlier, it was only chemical treatment part was there, but right now there are a lot of technologies getting involved into it, and since these laws are getting stringent day by day, so more industries which were earlier ignoring this field now looking into the proper water management within the plant.
Only one last sentence from me.
Yes, sir.
Yes,
And sir, there is
Dr.
one comment also which I wanted you to
Yeah.
comment on. There's one comment we have received, and I would request you to comment on that and give your closing remarks as well. So this is a comment received from one of the delegates. We think ZLD is not industrial friendly, but we are ready to compromise the environment as a whole and not ready to give natural environment to future generations. Sir, if you could comment on this and also give your closing remarks.
So whether you want industrial products comfort or environmental comfort, so there is a balance. Government is also very well. If you want to promote industries, effluents will always be there. But yes, how best you treat those effluent and discharge within the regulatory upon. No industry violates it. It is within the regulatory requirements. If regulatory requirement calls for ZLD, industries have to go for ZLD. But again, associated issues are there, disposal mechanism for salts, etc. The final remark is Dr. Abdul Kalam once said that by 2070, 90% of the industrial workforce will be from desalination industry. So all young engineers who are listening, be prepared to become CEOs of future companies, water treatment companies. Yeah, thanks.
Thank you. I think on that positive note, I am going to close this session. And